Now we're going to look at 8.2 on arithmetic sequences and series. So this is a special type of sequence. And let's look at the definition. So this one I will write out because there's a lot of derivation. I want to show you how you do it. So you have an arithmetic sequence. Basically, you have some sequence A sub n, like that. Let me redraw that. So some sequence like this. And each successive term, so each next term, there's a common difference. So A sub n plus 1, the next term, is the previous term plus D, meaning you add a certain amount each time. And when you subtract two terms that are in a row, right, like A4 and A5, you subtract them, they're always going to be the same thing, the same common difference. So D is called, let me write all this stuff down for you, is called the common difference. Okay, so this, notice though, this is recursively defined. So that's how we're going to define it. Now, we want to find an explicit form. So we're going to derive the nth term, or the explicit form, of an arithmetic sequence. Okay, so you have, so we're going to say let D be the common difference. But what I like to think of it as, though, is that you're adding D to each previous term. So the next term you add D, the next term you add D again. So it would look like this. So that you have A sub 1 is your first term. A sub 2 would be A sub 1 plus the common difference. And then A sub 3 would be A sub 2 plus the common difference. But A sub 2 is A sub 1 plus D plus D. A sub 4 would be A sub 3 plus the common difference. But A sub 3 is A sub 1 plus D, and then plus D again. You see the pattern yet? A sub 5 is A sub 4 plus the common difference. So A sub 4, though, is A sub 1, I'm looking right above, plus D, plus D, plus D, plus D. So we can see that there are 1, 2, 3, 4 terms, and the index is 5. There are 1, 2, 3 terms, the index is 4. 1, 2 terms, the index is 3. So how many of these D's do we have? So, right, it's one less. It's one less than the index. So A sub n is equal to the first term plus one less than the index. So that's the form we usually use. So this is, right here, I got to move this down a little bit. This is the nth term of an arithmetic sequence. This is the explicit form. So this is what you would need to know. Well, like know and work with, right? I mean, so you want to be able to understand that concept. Okay. So this is called the general term or the nth term of an arithmetic sequence. All right. Let's look at a couple examples now. So write the first 6 terms of the sequence. Let's take a look at this one. So write the first 6 terms of the sequence. Sequence that's given is quite simple. A sub n is 4 minus n. So you can try that, pause and try that. So just calculate it. Excuse me, plug in 1, A2, plug in 2, A3, plug in 3, and you see how this one's going to go negative? It's going to be 0 at that point. How many terms did I say? 6? Okay, so we're almost there. And then A6 would be 4 minus 6, right? So you just do that calculation, that's what you get. So this one is 3, and then 2, and then 1, and then 0, and then negative 1, and then negative 2. So if you subtract each of the terms term by term, so if you do 2 minus 3, subtract those, what do you get? 1 minus 2, subtract those, what do you get? 0 minus 1, you're getting the same thing each time. So you can just see that d is equal to negative 1. So, and then what's the first term? And then a sub 1 is given to be 3. And that's what you need to write out the terms of sequence. So you have D and you have A1. Those are the two things you need, like that. So A sub n is going to be A1, which is 3, plus n minus 1 times D, which is negative 1. And then you want to simplify that. So 3, then it would be minus n plus 1. Which is what we had before, right? So it's 4 minus n. Okay, so you can verify like that. So that's just checking it, right? It checks it off. All right. Oh, one thing is I want to show you. If you think of this as a function, f of n is equal to negative n plus 4, then what type of function is this? Like if you were to graph that, what does that look like? So what if I have f of x, negative x plus 4? That's a line, yeah. That is a line with a negative slope. So it's basically what you get, and I'll erase this in a second. So I'm not just going to show you. So what you get, I got to draw a line that's straight, vertical, I mean. So you get basically this line that's dotted, but it's up 4. So 1, 2, 3, 4. With a slope of negative 1. So it's like this. So basically, arithmetic sequence means that it's like a linear graph. So you're basically getting this graph like this, but it's just these individual points. So at 1, you're up at 3. So at 1, you're at 1, 2, 3. So you're just right here. And at 2, you're at 2. Right, so it's just those individual points. Okay, so that's what, usually I don't graph them. They're not very interesting graphs. Let's do another example. Okay, let's see. So given a sub n equal to 3n plus 5, show that a sub n is arithmetic, is an arithmetic sequence. Okay. So we basically want to find the general. So this is a little more than I would probably ask right about now, but you want to find a sub n, which is given, a sub n plus 1, and then we want to take a sub n plus 1, subtract a sub n, and see if we get d every time. So that's essentially what we want to do. Now, we want to write a few terms out just to get a feel for it. So to get a feel for it, let's write out a few terms of the sequence. So that's kind of what you want to do. You want to that's what math is about too. Is just you want to write stuff out, test stuff, plug things in, see what happens, and get a feel for what's going on. So let's do that. So A1 is 3 times 1 plus 5. So that's 8. A2, 3 times 2 plus 5. So that's 6 plus 5. It's 11. And then A2, A3 is 3 times 3 plus 5. So that's 9 plus 5. So that's 14. A4 is 3 times 4 plus 5. So that's 12 plus 5, which is 17. So in each case, if you subtract these things, what are you getting? I mean, it should be kind of clear that it is, but so if you do, where is it? Let's see, let's just highlight here. So let's highlight my 8, 11, 14, and 17. Those are the 4 terms of the sequence. So if you subtract those, 17 minus 14, what is that? 17 minus 14, that's 3. 14 minus 11 is 3. 11 minus 8 is 3. So it's looking like, so it looks like, this is kind of what we're thinking. D is equal to 3. That's your thought, your conjecture. That's what you believe it must be. So this is what you do. Remember, what our goal then is to eventually do this. So this is the step that takes a little bit of work beyond just plugging in numbers. We're going to create a sub n plus 1 in general like that. So let's do that. Let's put in a sub n plus 1 and get, so I'll write out a sub n. So a sub n is this. Okay, so here's your a sub n. Then write out a sub n plus 1. So you're going to substitute n plus 1 wherever you see just n, just like that. So that's where we're going to place it, right there. Now simplify that. So you get 3n plus 3, and then plus 5. 3n plus 8. So now take a sub n plus 1 and subtract a sub n. So if you take 3n plus 8 and then subtract. Don't forget your parentheses. 3n plus 5. You can see that the n's will annihilate each other. And so you get 8 minus 5, which is equal to 3. So the common difference there is indeed 3. That actually proves it, because the n plus 1 is the next term every time. You could actually do n minus 1 and then do a sub n minus 1. So if you did that, you'd get this one. So it's 3n minus 3 plus 5. So it would be 3n plus 2. And then if you did a sub n, you can check this. This is not something I wanted to spend time on. You'll get 3 as well. Okay. So, conclude. I didn't leave myself enough room on this page. So, to conclude, therefore, you found that common difference for every term. So, therefore, that's how it's defined. The sequence a sub n is arithmetic. Okay, moving on to the next example. After that, we'll stop there and do another video.